Hello everyone, good morning, good afternoon and good evening. My name is Vishwadeep and I welcome you on all PW Gate Wallah channel. Today, lecture number 3 of operating system, and we are going to talk about process states and process state transitions. Yesterday we already learned about what is a process, what is context, what is context switch, what are the 4 different segments or sections in which every process is stored in main memory. Now we will talk about how these processes are behaving, when process does what, based on that how its state is defined. So let's get started, but before that I would like to have a small message from you all. Are you ready? Are you ready for today's learning or not? Just because today's session will be very, very interesting and very, very informative. So, first of all, we will start with process states. There are different states in which a process can be. But currently, process is doing what? Based on that, its state is called. Like you are having a state of preparation, then qualified, state qualified. How? But that qualified, gate qualified state comes when, exactly when you will be having your scorecard, right? So what exactly you are doing, based on that your state is defined, exactly with processes also. Okay, so process state is nothing but defined with the help of what a process is doing. So I'm writing that defined by the current work of process. Whatever currently process is doing, based on that its state is defined. Okay, there are different states. You can see new state, ready state, running state, terminated state, waiting, which is broadly called as blocked state. What these states are? Okay, so when you install some applications in your phone or in your computer system, but when you don't use them, then the process which you have installed, not using them, that state of the process called as new state. So all those processes which you are not running, but there are processes existing, like in this particular computer only. Let me see. Okay, this particular computer, I am not using Microsoft Word or Microsoft PowerPoint. Am I using? No. So Microsoft PowerPoint process is there, which is there with operating system. OS knows that there is a process of Microsoft PowerPoint. That particular process, if I'm not using, where it is kept, its state is called as new state. What it is called as? New state. Okay, so new state means all those installed applications which you are not using, those applications, those processes are known to be in which state? New state. Fine. Okay, now next is ready state. Okay, in multi-programming system, how many processes can be in main memory at a time? One or more? Tell me, comment. How many processes at a time can be present in the main memory? More than one. So many processes are there in main memory, yes. But among them, how many processes are running in CPU at a time? At a time, a specific time. Only one. Why? I have only one CPU. One CPU can run only one process. Then, if one CPU can run only one process, then that process running in CPU. What about remaining processes? What happens? There are so many processes which are in waiting. Waiting of what? Waiting for CPU. So these processes are ready and they are ready to run. As soon as the chance comes, those processes will execute on CPU whenever chance comes. So what those processes are doing? Waiting for CPU and they are ready. So all such processes which are there in RAM, you brought them in RAM, but among those Only one process can run in CPU, remaining are waiting for CPU, and such kind of processes are called in ready state. In ready state. So if I do have ready state definition, what I'll call as all those processes which are ready to run in CPU. So the processes are in main memory. You wanted to execute them, but of course every process cannot run together now. One process at a time CPU runs. So whichever process CPU is not running and that process waiting for a CPU will be in which state? This ready state. Got it? So ready state, when a process is waiting for the CPU, called as in ready state. So the process which is running in CPU, what it is called as? A process in running state called in running state. If a process is executing in CPU, its state will be running state. So what process is doing? Executing in CPU. That's why state is running state. Okay. Now, if process completed, if process execution completed, called as terminated state. So if process execution is done, the process will be in terminated state. And if let's say if a process is going for IO operation, so if process is executing in CPU, called as in running state. Process is waiting for CPU, ready state. If process is waiting or doing IO operation, whether waiting for IO operation or doing the IO operation, process will be in this blocked state. Which state? Blocked state. Why? Just because process is blocked until its IO operation is done. When IO operation done, tata bye bye, process again will be trying to execute. So the 1, 2, 3, 4, 5 state and their definitions are clear. I want response here. I told you in the last class also, my dear friends, that if you will not give me response, I won't understand that you guys are listening and understanding it carefully. And if I don't get that particular thing, then definitely it will be a problem. For me, I need motivation. Of course, you also need motivation for studying. I also need motivation for teaching. So please tell me. So what happens? What happens? All 5 states only I have explained you. All the definitions are clear. If yes, then let's go ahead with the transitions. You can see some transition diagram where process can transition from one state to another state. Yellow color lines or edges. If you understand edges are there. One, this, 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 and this. So let's say there are so many new state processes. Currently, we are not executing them. Among them, if you double click one of them you double click, what happens? That process will be admitted. So that process comes into main memory, comes to main memory. It is created, the process is created in main memory. It will be stored in 4 sections. Operating system will make its PCB and the process will be initially entering into ready state. Just because as soon as you double click on the process is created, it comes into main memory and the process will be added into the ready state. One of the ready state processes, operating system selects that if 4 processes P1, P2, P3, P4 are there, then among them which process will be scheduled next to run on CPU, OS decides that. So OS runs that particular process next by scheduling. That's why the ready process, one of the ready processes takes the transition and goes to running state. Dispatcher will do the context switching. That's why process will be able to reach to running state. The scheduler will select the process. So these 2 things you will understand. I will explain, don't worry. But you will understand today only what is scheduler and what exactly this dispatch is. So ready to running transition happens when one of the ready processes selected to run on CPU. Now, a running process can have 3 different transitions outside. Either running process completed, then it will go to terminated state, exit. If a running process wants to go for IO operation, it will be taking this transition to blocked state. If let's say running process does not want to go for IO operation and also does not go for termination also, just because it is not completed, but a running process forcefully taken out of the CPU. Preemption. Yes, we have seen this in first lecture. Preemptive multiprogramming, where a running process forcefully out of its wish taken out of the CPU, then where it will go? Process is not completed, no, so it will not terminate. Process is not going for IO, no, so it won't go for blocked state. So if a running process is preempted forcefully against its wish, then that particular process will go to ready state again, just because it is again ready to run. Whenever its chance comes, it will run again. That's why it will take the transition when preemption happens to ready state. Understood this? Everything, all the transitions. One more is left. When a process is in blocked state, its IO is going on, or if it is waiting for IO operation, when the IO operation completes, that process doesn't go to running state again directly. No, after IO and event completion, look at this, the process takes the transition to ready state. It will be added into the ready state. Then among the ready state processes, again operating system selects next process to run with the help of scheduler. So what happens? Blocked state process, after IO completion, it will go to ready state, not into the running state. Now if you see, there are questions in the history about this transition diagram. And what type of questions they may ask? They have asked that a running process, when goes for IO, it will take the transition to ready state. False. When running process goes for IO, it will take the transition to blocked state. A ready process can have transition to blocked state directly. No, false. A blocked state process can have a transition directly to running state. No, false. So there are certain such kind of statements. Through this transition diagram, you can easily answer them if you remember this. And this is one of the easiest concept to remember. Easiest concept to remember. Okay, understood? Everything which I explained written over here. All the installed processes are known to be in new state, which are not running. If not running, then definitely those processes will not be in main memory. Then processes are not in main memory, but their details are there in a list with main memory. I will explain that also in some time. Wait. The processes which are waiting to run on CPU are known to be in ready state. Explained this. Running a process running on CPU has its state running state. A completed process has its state as terminated state. Blocked, all the processes which are waiting for any IO or event in blocked state. Transition also I have explained here. Everything I explained, now I am writing it. Why I am showing you this? Just because you don't have to write it again. That's why. When process is admitted by operating system, taken the transition new to ready. Ready to running. When a process is dispatched to CPU from the ready state, then ready to running, it will take the transition. Running to terminated when a process is completed. Running to blocked when a process goes for IO operation from running state. Running to ready when a process is preempted against its own wish forcefully. And blocked to ready when a process completes IO or event. Then it will take the transition. Now look at this. When process is in new state, the process will not be in main memory. Main memory means RAM. Process is not there in main memory for sure. When it is admitted, then it comes to main memory. When it goes for IO, when it goes for running, still process is there in the main memory. When process is going for running means we are sending the context of process. Those register values operating system is sending Dispatcher is sending from its PCB to CPU. Process instruction, data, stack, heap, everything is there in main memory only. Then last, when process is in blocked state, still process content is there in main memory only. So till what time process will be there in main memory? When it will be running, it will be there in main memory. When the execution completes, termination happens, then all the resources the process will leave. Process has taken the main memory space. Yes, it will be released when process terminates. So here, after going to terminated state, again process will be removed from main memory. Okay, removed from main memory when it takes transition to terminated one. So when process is in new state, not in main memory, terminated state, not in main memory, when process will be in these three states, then process will be there in main memory. Can you please tell me if everything is clear? Till now, everything you guys are understanding? Tell me, everything is clear or not? So if process is not there in main memory, then where it will be? It will be in the secondary memory disk. The process will be there in the secondary memory disk. And here also, when it is terminated, removed from main memory, then it will be only in the disk. Okay, now next thing is among all the transitions, there are only two transitions which process can take by its own. When process wants to take transition, process can take the transition by its own. Other transitions will be done by operating system. And what are those two transitions? Running to terminated and running to blocked. These are the two transitions which process can take by its own. Apni marji se process can take the transition 1 and 2. That's it. Yes. Preemption can process do by its own? No, of course process will not preempt itself. Why? Why process itself will forcefully taken it out or take it out outside of the CPU forcefully? Why? No. When process the admission, process cannot take that transition. OS will do this. This transition, OS will do this. This transition, OS will do this. Understood this? So two transitions are there which are voluntarily taken by the process, running to terminated, running to blocked. Are you guys understanding this? Then we have seen a non-preemptive process state or non-preemptive, multi-programming also, where preemption of a running process was not allowed. So if preemption is not allowed, then this transition is removed. Look at this. This transition is not there running to ready. So if a process is scheduled to run, process will leave the CPU by its own wish. I have written the exact same line. In non-preemptive system, the process once given to CPU, process leaves CPU only by its own wish. So two transitions possible. Running process can terminate by itself or will go for IO by itself only. It will not be forcefully, it cannot be forcefully taken out of the CPU. That's why this transition is removed. In old PYQs, this is one of the question. This kind of diagram given and ask that what type of operating system it represents or system it represents. Definitely it is non-preemptive system just because this transition is not there. Understood this? Understood this? Okay. How much time process spends during its execution in CPU versus IO? If CPU's process is spending more time in CPU execution and less time on IO operation, then the process is called a CPU bound process. Like Google Chrome. Google Chrome runs more on CPU, lesser on IO. For IO, it uses only your screen. Apart from that, not much. Sometimes if you are watching some lecture on your Google Chrome web browser, then some speaker, but not much. More heavily it will use the CPU. CPU bound process, if process is intensive in terms of CPU operation, it spends more time on CPU, less on time on IO operation, called as CPU bound. IO bound process, when a particular process is spending more time on IO operation and very less time on CPU, then it is called as IO bound process. Okay, now I will give you a very interesting example. But before that, you guys will have to tell me, have you ever installed any application in your Windows operating system, laptop or computer system? Ever? Exe files are there, you may download them, or maybe you can bring them from somewhere. And if you are running those executable files, exe files, those are installer, nothing but installer, then what happens? Have you experienced that? If yes, then my next example you will understand like anything. Have you? Tell me. So if you have installed some application, you double click on it. Before that, you downloaded the exe file. If you downloaded the exe file, that will be in new state. As soon as you double click it, then it will first come into ready state. CPU will, okay, operating system will bring that process into main memory and it will come to ready state. Then after a certain small duration of time, which you don't feel gone, but it is there, after certain small delay, operating system selects that process to run. So that particular process starts running, and when it starts running, you will have some kind of dash, some kind of progress shown. Its logo or some kind of small window comes in front of you. So as soon as that installer starts running, you have some response of that particular installer. And after some time, you have a particular window open and nothing is happening. Now, what is that window? Window is, in this particular application, there are 3 versions. Customized version, in which only one application is installed. Second, customized version, in which 2 applications are installed. And last is recommended overall, all the suites like 2, 3, 4 applications, and it's all the features are there. So which version or which particular in which particular manner you want to install that particular application? If you have done that, you will feel it. You'll feel it. So when that particular window comes, execution is not going further. Your installer is not executing, it is not proceeding further. Why? Just because the executable file application or that process, installer process, is waiting for your inputs. So what happens, as soon as that installer executes, after some duration, it will need some event or IO operation to be done. That particular application will take transition to blocked state. Now, until you click one of the options and OK, that process will not go ahead. No, just because waiting for event. Event is what? User will select one of the installer option and then click in OK. When you do that, then only process can go ahead, otherwise not. So process is in which state? Blocked state. Now what happens? What happens? Now, as soon as you click on one of the options, customized option, only one application, basic mode, and then click on OK, then the process will be coming to ready state again. After some time, it will get the CPU, then it will again go into running, and you may have some more progress shown. Some dot or something progress will be shown to you. Now, after some time, again another screen comes and the software stops. The installer stops. What is that installer stops? Why? What is that particular thing for which installer stops? installer stops for agreement. There is a big software agreement which you never read, and it is asking that do you agree or not. If no, then installation will be cancelled. If yes, then only installation will go ahead. So you anyway, without reading it, without understanding it, you click on agree, I agree, and then click. But when that particular window comes again, the process was again in blocked state. And then when it goes back to ready, when you click on I agree and next. So when you click on next, again procedure goes ahead, running, 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 and running. Then what happens? Execution of that particular entire process completes. Installation happens, yes. Completed, yes. At the end, when installation completed, that particular window automatically gets closed. Process terminated. Now you can imagine every situation happening in your computer system, and not imagine, actually visualize what is happening. And this is what the computer systems magic, which we are relating to the clear concepts. Tell me, maza aaya? Are you liking it? Are you enjoying it? This is what practicality I told you about. Next thing, process scheduling. I'll ask a very simple thing to you. Let's suppose you are making a trip to a new city, and in that new city, only one place you will have to go. Let's say place of your uncle's place. So if one place you will have to go, you do not schedule anything. You just go, reach to that place, whatever work you have, do it and come back. That's it, done. No scheduling needed, no any management needed, nothing. But let's suppose you are going to a new city, and in that new city you will have to visit 4 different places. Then 4 different places you will schedule ahead, one day or maybe a lot of days ahead, when the plan happens. These 4 places, this should be watched in the evening, this should be watched in the afternoon, this should be watched in the morning. Route will be something like this. You schedule all 4 places. Why? Just because you want to enjoy all 4 places at their best possible way. If some place should be visited in the evening, at the sunset time or later on, then you go there on that particular time. If some particular place you should visit in the early morning so that you can enjoy some specific show or something, then you should go there at first place, as a first place. So this scheduling is needed. Why? Just because you have multiple places to cover and you want the best output of your day so that you can enjoy most out of it. And I'm sure, 100% sure, you might have seen this kind of a thing when you plan for shopping also. That I will start from this area, I will purchase these items, then this area I'll purchase these items, then from there I will walk to that particular street. There the best possible chart is available. Then next shop is for best possible dosa. I will have both, and then I will walk back here, here, here. You plan your entire city visit. Why? Just because you don't want to spend extra time, still you want to enjoy your shopping most. And of course, your favorite food too. Right? Happened ever? Yes. So it's very simple. The process scheduling also needed when the multiple processes are there and we want one process to use CPU or IO or something so that the best possible output can come of this process execution. So when multiple processes are there, which process should be working next for what, that should be decided in the proper manner so that the output of all process execution will be efficient and in lesser time. So why? process scheduling needed to achieve better efficiency and performance. But processes will be scheduled from where to where? Before that, we need to understand three different lists. Three different lists. What are those lists? Job queue, ready queue, device queue. Have you heard the term queue? Sune ho. Have you heard the term queue ever? Queue is nothing but a list where you can keep something. So when in some of the states multiple processes are there, then operating system maintains a list so that operating system will know that these processes are there in new state, these processes are there in ready state, and so on. So at a time, so many processes are possible in the new state. Yes. So how OS will know that what all processes are there in my new state? OS maintains a queue, job queue. All the new state processes are kept into this list. Just because more than one processes are there, so operating system maintains this. A particular list where all the new state processes are there. Second, ready queue. Of course, in the ready state also so many processes are there. So OS maintains another queue. That particular queue is ready queue, in which OS keeps all the ready state processes. All the ready state processes are kept into this list. Which list? Ready queue list. Okay. Now look at this. How many processes at a time in the running state? Only one. So do we need a list of it? No. List is needed only when more than one processes are there. In running state, only one process. Then it's okay. In terminated state, I don't need it. The process which has completed, why should I need the tracking of it? I don't need any list for it. So no any list for these two states. For this one, of course, for blocked state, again we will need a particular list. And what is that list? Called as device queue. All the processes which are waiting for a device kept in its device queue. Now, there is a small concept over here. The concept is, boss, operating system maintains overall only one job queue. All the new state processes kept into it. Operating system maintains only one ready queue. All the ready state processes kept into it. But operating system maintains multiple device queues, one for each device. Only one, but one for each device, which means there will be a queue of printer separately, there will be queue of camera separately, there is a queue of hard disk separately. For every IO device, a separate queue is maintained, device queue maintained. If one process using the hard disk, other four processes are waiting for hard disk, then all four processes will be kept on hard disk queue. If two other processes are waiting for printer, then those two other processes are kept in printer's queue. So separate queues for separate devices are made. Understood that? Now, now. Look at this. I have explained this already. But this is a very exclusive content. Again, very exclusive content. When you make main memory, in main memory operating system part is there. In operating system, we have job queue, we have ready queue, we have so many devices queue, then we have all the TLBs, oh sorry, PCBs, PCB of process P1, P2 and so on. Everything is there in the OS. Job queue is there in operating system part in main memory. Yes, it helps operating system to understand what all processes are there which are installed but not being used right now. Which all processes are there in main memory then? Only those which are in either ready state or running state or device waiting state, blocked state. So processes are there in main memory, but whichever processes are there in main memory, those will not be in this job queue list. Job queue list will be just a list. It will be having only the list that which particular application or which particular process is there installed but not using. So the new state processes will be in your secondary memory disk. When you admit them, then a particular secondary memory process will be brought into main memory. Somebody asked this question just few minutes ago that sir, in BAC interview this question has been asked. I want to purchase Khazana without batch, not possible. Khazana is only included with the batch. You take the batch, then take the Khazana. Separately, not possible. Okay, next is different type of schedulers. So many processes are there in new state. Among them, which process is admitted next to ready state? That particular thing decided by long-term scheduler, job scheduler. Job scheduler or long-term scheduler. So it brings one of the new state processes to ready state. So many new state processes are there. Among them, which process will go next to ready state? That particular thing done by long-term scheduler or job scheduler. Okay. Next is short-term scheduler or CPU scheduler. So many processes are there in ready state. Among them, which process next should be running? That particular thing decided by CPU scheduler. So CPU scheduler does what? It selects one of the ready processes to run next on CPU. Boss, huge term difference is here. This one say it brings, means this long-term scheduler selecting one process from new state and bringing also that new state process into ready state. Bringing itself, yes. But this short-term scheduler, there are so many ready state processes are there. Among them, it is just selecting that which process will go next to CPU for running. It is just selecting, not taking that process. Why not? Just because this is Dawn and Dawn does not do the dirty work. Dawn has lot of small gundas under him or her, whichever Dawn is. So big Dawn and then small gundas are there, his worker. So if he says that take this fellow and take him to that particular jail, put him in the jail. then what happens? Or put him in the room. He just selects that among these all 4-5 members, select this fellow and just take him and just put him in the room. He is just selecting, not doing. He will not go along with those people and put him into the jail or that particular room. No, he has other fellows to do that task, and other fellow is dispatcher. Dispatcher takes the process into main memory. Yesterday I told you, sorry, in the CPU. Dispatcher does that context switching ka work. So scheduler just select, and dispatcher dispatches the process, actually takes the process to CPU for running. So that's why you can see over here in this diagram, scheduler dispatch. So scheduler will schedule one process from ready state, selection done, then dispatcher will take it to running state. That's how that particular short-term scheduler and dispatcher will be working together. Fine. But why these two terms, short-term scheduler and long-term scheduler? Based on the frequency of requirement. This long-term scheduler is required very less frequently in long term. That's why long-term scheduler. Short-term scheduler is required quickly, very frequently. That's why short-term scheduler. You can easily understand how many times you select a new process to open, double click and open a new process, very less frequently. But how many times switching of the process is happening within nanoseconds. So scheduler, this scheduler, short-term scheduler is required within nanoseconds. But this scheduler required sometimes in minutes, sometimes in hours, sometimes in a few seconds. That's why long-term and short-term. And what is this medium or mid-term scheduler? This mid-term scheduler performs swapping. And what is that? For that, we need a person who plays game on phone. Do we have any person who plays heavy games? Heavy means a very big game which takes a lot of processing and lot of RAM. Do we have any person in the class who plays game or played game ever in the phone? Okay, look at this. Let me explain you the concept of this. See, this is main memory RAM. In main memory, some space occupied by operating system, and in other space, user processes are there. The games, etc., whatever you play, WhatsApp, Gmail, whatever you open, all these will be in the RAM when you run it. Okay. Now look at this. You are playing a heavy game, so no any other application you have opened. Heavy game you started playing, and that particular game you brought into main memory. Very big, occupied a lot of space in main memory. You are playing the game, enjoying, sitting in the one of the corner of your home, and suddenly one pop-up message comes on WhatsApp, and the pop-up message is, did you submit assignment? This message is from one of your best friends who cares about you. Okay, very caring best friend you have. So he has a message for you. Message is, did you submit the assignment? Now your heart will stop beating for 1 second and like, assignment? What assignment? Which assignment? Which subject? Do we have any pending assignment? Oh my God, I am gone again. So what you will do? You will pause the game. You are not closing the game. You will pause the game and you will open the WhatsApp application to read your best friend's message. Happened ever before? So when you start reading WhatsApp message, what happens? Okay, let's say WhatsApp you open. So WhatsApp application, if you are opening, then definitely WhatsApp will be coming into the main memory and it will be executing. Then you will ask your friend, which assignment? Your friend immediately said, I knew you will forget. Don't worry, I have sent my copy over mail to you, over Gmail to you. Just check, change the name and some variable and some changes you can do and submit it here before this particular time. Your friend has given all these detail in message. Of course, you will try to kiss your best friend. Ah, you are only my best friend, but you don't do that just because you don't show emotions. But it's okay. You will send, Hara, thank you. I will do it now. Okay, so you leave that chat, then go to the Gmail application. Now you open the Gmail application. Gmail application also will be brought into main memory. And in Gmail application, when you see there is a mail from your one of the best friends, he has only sent that particular mail. You will open the mail. In the mail, there is a text file. You open that. Now let's say text file is opening in one of the text editor software. But the problem is my main memory is now full. We do not have space in main memory. But you as a user want to open the text editor application. Process, text editor. How can I open? I do not have space. Operating system will not deny you. That OS will say an error message, hey, main memory is not free, I will not open it. No, it doesn't happen. To make your app experience smooth, what operating system will do? Operating system will check, do we have any process which is not being used currently? Do we have any process which is not being used currently? Yes, game application, it's been long that user has used it. For some time, temporary basis, OS will remove that game application from RAM to bring the new application text editor so that it can be opened and user can use it. So what happens? For temporary basis, one of the process selected from RAM and taken out from RAM sent to secondary memory. So that this space is free, and now this particular space can be used to bring that new application text editor. So you open the text editor, very smooth work. You change the name, variable, whatever you can with your possible, little present brain over there, and then save it. Then you again go to Gmail, you send that particular mail to your professor, submission, etc. You do. Then you again go to WhatsApp application and you send a message, thank you Ra, I have submitted this, see you tomorrow in college. Then when again you go back to game, before that you close all the remaining applications. So text editor removed, Gmail removed, WhatsApp removed. Now again when you open the game, what happens? If you are a gamer, you will feel and you will observe it that game loads again. Have you observed it ever? That game again shows that, oh, loading again. Why loading again? I was playing it before, na? Why? You are loading it again from the disk. Because of this reason, just because operating system has removed that game so that RAM can have extra space. Now you want to play it again? Yes, as soon as you go back to that game again, that particular game will be again loaded into main memory. See, you will not lose any progress. The actual page which you left before, you will be landing to same page. When you will click on resume, again it will be resumed from that place only where you left. You will not lose your progress, no, but it shows that game is loading. Why? Because of this process. Understood entire scenario? This is purely practical scenario, complete story which I am relating you guys with operating system concept. That's why I told you very exclusive content it is. Very, very exclusive. Now listen, there were so many processes in RAM. Yes, why operating system has chosen game only to take out? This medium term scheduler, a program of operating system, acts here and decides that which among all main memory processes I can remove. Remove means swap out so that RAM can have space. And then again needed, when needed, that game again comes back in, swap in. This is completely together called a swapping process. So who will do swapping? Medium term scheduler. It will decide that which process will go out, and if multiple swapped out processes are there, then which one will come back again in RAM. That will be decided by medium term scheduler. So this swap out and swap in is done by whom? This medium term scheduler. Which process selected? It selects based on some kind of parameters. Now, if a process is swapped out, then what will be the state? The process when was in main memory, maybe it was in running state or ready state or blocked state. But if process is swapped out of the main memory, where it will go, what will be the state called as, then we need to have another process state transition diagram which can help us understanding that. Two new state I'll have to add. Why two? Just because a process which is in main memory only can be swapped out. Now you tell me, by this class only I explained, if a process is in new state, is it present in main memory? No. If not in main memory, can it be swapped out? No. A process in terminated state in main memory? No. Can it be swapped out? No. A process is in running state. Can you swap it out? It is something like a particular bike is running and you are stopping it, or you are, touching its tire. Running bike and touching its tire very hard. You will burn your hand. You will just, injure your hand. Running process cannot be swapped out just because it is actually running in CPU. So which process? Ready state process in main memory? Yes. It can be swapped out? Yes. Waiting or blocked state process in main memory? Yes. Can be swapped out? Yes. So either a process will be swapped out from ready state or waiting state, means blocked state. So if a process is in blocked state and if it is swapped out, then it will go to a new state called as suspended blocked state. So when it is suspended, means swapped out, then it is going to suspended blocked state. When it will come back again, resume, then it will come back again into same blocked state. A ready state process, if swapped out, then it will go to suspended ready state. So if suspend happens, suspended ready state, and suspension comes back, then again resume to ready state. Sometimes it happens that process was waiting for IO operation and then it got suspended. But when it was in suspension, its IO operation completed. So if IO operation is completed, it will no more be in blocked. Not in suspended blocked, not in blocked. So it will go into suspended ready. Why? It is still suspended, means not in main memory, yes, but its IO operation is completed. If IO operation is completed, it cannot be in blocked, either of these two. But it is still in suspended state, so it should be in suspended. So it will go into suspended ready when the IO or event is completed, when the process is in suspended state. Did you understand this? Did you understand this? See, I have a very simple example from cricket. let's say a particular person got injured, injury happened, and that particular injury will take the player out of the selection for next tournament or something for, let's say, 2 months. So that fellow is now blocked just because waiting for the injury to heal. 2 months. But during that injury break, that player has had some kind of disciplinary action, and because of that, the player got suspended for 6 months. Now player is suspended also and having the injury problem also. So 6 months suspended and 2 months for injury together happening. So the player was blocked due to injury and after that got suspended. So suspended, blocked. Now after 2 months its injury is gone. The injured player's injury healed. Now player is training but cannot be selected. Why? Just because suspended. But the player should be in the blocked state? No. Why? Just because player's injury is healed, gone. So the player, when suspended also and blocked also, now block has opened. The player is no more injured player. It is suspended player. So the player will go into suspended ready. When the suspension opens after 6 months, then player will be ready to be picked up for the next tour or tournament. Simple. So if it is picked, it will go to running. Done. Then when he will retire or she will retire, then terminated. Done. After that, the player will not play again. Okay, so today we have seen a lot of different types of schedulers, process state transition diagrams, and many more things. I hope you enjoyed and learned good things, practicalities of different states and transition and different schedulers. Tomorrow we will not have any class. So tomorrow is break, Saturday, Sunday, no classes. Monday to Friday, next Monday onwards, we will again resume the classes. Okay. So we will meet again on Monday with the new chapter, process scheduling or CPU scheduling, where you will learn a lot of different types of scheduling algorithms with some numericals to be discussed in the class. Okay. See you again in the next class on Monday. Have a great day. Happy learning. Thank you. Bye-bye.